Yes. Hello, Eddie.
Good evening, everyone.
Yes, good evening.
It's a great pleasure for us to continue the geospatial cloud computing using Python this evening. My name is Eduardo Kwambuama, and today I'll be the moderator for this session, whereby we are going to talk about the cloud computing platforms that are available. With this particular session, the main focus will be on the Digital Africa platform, which is now in existence in Africa, and you'll be able to use that one throughout the period of it. Let me turn on my video. Sorry for my, I think, yes, on the lights, yes. So that everybody will be able to see me. Okay, so this session, we'll be talking much about the DE Africa platform as one of the cloud computing platforms that have actually been there and how we can actually utilize it. I think for the past week and yesterday, we've actually been introduced to the basics of Python and how to work with it within the space of wherever you'll be working or wherever you are. So as it stands now, today, what we'll be doing as part of the session, that's the cloud computing. We'll actually build on top of what we've learned so far. And we are going to also use most of the Python codes or the language that you use within most of the works that you'll be doing. So before I start to go into the real details, I just want to give you a simple background about Digital Africa and what they are all about. Then we'll go into the Digital Africa sandbox for the next step. So Digital Africa actually provides a routine, reliable, and operational services for Earth observation data sets across the African continent. So the focus is on African continent to actually enable decision-ready products by enabling policymakers, scientists, private sectors, and civil societies to address problems such as the social, environmental, and economic changes on the continent, and also develop an ecosystem for innovation across various sectors. So areas like agriculture and food security, water resource and flood risks, land degradation, coastal erosion, and urbanizations are thematic areas that's actually of concern to the Africa. And our mission is to make sure that you'll be able to use Earth observation data sets to aid in monitoring these things. So to be able to do that, we can't just give you the data sets, but we also try and give you a platform for you to access the Earth observation data sets that we currently have on the platform.
Hello, Eddie.
And the good news is it only focuses on Africa.
Your screen is not showing.
Currently, we have over 3.5 terabyte data, which is being hosted on Amazon in Cape Town. And as time goes on, you continue to add more data sets to it. So when we go into the sandbox, I'll talk mostly about some of the data sets that is currently available. So not only are we giving you these data sets for you to work with, we also provide technical support to our users to be able to also utilize it, especially for the area of study that they are working in, whether it's within the thematic areas that I talked about previously.
Hello, Eddie.
So that's what the Africa is actually all about. And at this section, we will focus on the sandbox platform. They have the AWS services.
Edward.
Platform
Eddie.
Services, but this focus will be on the sandbox, so you won't actually deal with the other platforms that they have. Maybe in the near future, probably there'll be a session for that, so that you'll be actually going to them and see how best we can use those.
Hello, Edward.
So if you are interested to learn more about it, you can visit the
Edward, your screen is not up, and it is. Yeah, looking at your sharing, but it's not sharing. We are talking about you can't hear, so check your internet. Let's see. All right.
Hello, sorry for that. Okay, but please, I hope you heard whatever I just said. I'm just very sorry.
Yes, I think if you can share the screen, and I thought you were sharing something for them to see. So if you can share it again and then give explain again, I think that would be helpful.
Oh, okay, so very sorry for that. I just learned that. I thought my screen was sharing, but very sorry for that. So in a nutshell, that's what I talk about Digital Health Africa, the thematic areas that we are focusing on, and the vision of DA Africa to provide these routine, reliable, and operational services across the Africa continent. And these are some of our data sets that the Digital actually have, but we'll talk more about it when we go into the sandbox for that. Okay, so let me just stop sharing. And now let me open the DA Africa platform. Okay, so I'll put the link in the chat so that all of you can actually have access to it. Where is the chat? There's the chat. Okay.
So Eddie, so it helped you. Do we need an account before we can access what you are giving us, the URL that you're giving us?
Okay, sorry. So I've put the information on the chat, the link to the sandbox. And this can be found at the sandbox.digitalearth.africa. So if you can actually follow along with me, once you go to this session, you see what I'm seeing right now on the screen. That's a Digital Health Africa sandbox interface at this section. So the sandbox actually built on top of Python. So having a lesson in Python for the past week and yesterday is actually a great start for you to be able to actually utilize this session here. Once you come to this page, the next session is to go to the login or sign up. Once you click on the login and sign up, it will bring you to the login page. If you don't have any accounts or if you haven't registered beforehand, please go to the sign up by clicking on the sign up and provide an email, a name, and a password. Please provide a valid email because once you click on the sign up, a code will be sent to your email. And please open a new tab. Don't use the old tab. Please open a new tab and go to your email and copy the code that will be sent to you and bring it back to the sandbox and come and use it to validate it. So please use a valid email address, preferably Gmail. Provide your name, that, and the password. Once you provide these three things and you click on the sign up, a code will be sent to your email. Copy that code and please come back to the page where it asks you to enter the code. Put the code there, then click on validate. So once you click on it, it will actually open another page for you. If you've already registered, all that you have to do is come into the email, provide the email that you put up there, then enter your password here. So once you click on the enter of the password, it will log you in. If it's not successful, it will actually give you a message to you. Okay, so this is actually the cloud computing interface. So DEA Africa actually provide you two different instances. The first instance is the 2-core 16 gig memory. And the second instance is the 4-core 32 gigabyte of memory. So most of our machines uses the 16 cores, but I think most of us have the 16 gigabyte of memory to use. But if you have a normal machine, that's 8 gigabyte of memory, and some are 4 gigabyte of memory. But these ones actually are the 2 gigabyte of memories that are available for you to use. In case the area that you are working in is quite big and you need more processing cores, if you look at the information at the top here, you can reach out to the team for them to actually provide you up to 120 gigabytes of memory, depending on the area that you are working in, for 3 months, so that you'll be able to use it to work within the area that you are working in. The good news is you can actually request this large instance of processing memory at no fee, at no cost. We just give it to you 3 months, because you know that the area that you are using it to work in is actually important, especially when it comes to the African session, or the African continent. So it can give you up to 120 gigabytes of memory for you to have access to the platform and run it. But as it stands now, by default user, you have an access to either the 2 core 16 gigabytes of memory or the 4 core 32 gigabytes of memory, which actually can do a pretty good job depending on how you also develop your workflow to make it look quite faster. So if you have been able to do that, what I'll do is I'll just click on the start, then it will just boot up the instance for me. So in case you also had a session, just click on the start, then it will boot the instance for you. Sometimes it takes a little while, depending on depending on the internet connection that you have. Sometimes it actually takes some time, but as it stands now, you can actually click on it, then wait for it to start booting. Prior to this, I actually booted the one that I was going to use, I actually booted it up so that you won't actually take much time whilst you are waiting for it to load. So if anyone has been able to boot his, he can start go with me, or I can wait for additional 2 minutes so that all of us will be able to start our sandbox instance and we can continue.
Yes, the boot 2 minutes will be very important.
Yeah, some 3 minutes will do, please.
Okay, all right. By Edward, I think whilst we are doing that, we want to find out what are the benefits we can get, or what leverage can we get by using Digital Earth Africa?
Please, if you're having any challenge, you can raise up your hands using the raise hand buttons. Then I can call upon you if you have any questions, so that I can answer the question whilst I continue the session.
So whilst we continue, John Nesiama was asking, what are some of the benefits of using the Digital Earth Africa?
Hello?
Yes, Edward, can you hear me?
Yeah, Mike, I can hear you.
Yes, so John Nesiama was asking, so what are the benefits of using the Digital Earth Africa whilst you are waiting for them to set up?
Oh, okay. So one of the good benefits for using this platform is the avoiding of downloading satellite imagery data, especially from USGS and also ESA, that's Sentinel. If you have those information, if you know to download the data and to process it to the standard that you can use it for whatever work that you want to do, Day Africa actually provides the level 2 analysis ready data. So once you get hold of the data, you start working right with it. You don't have to do any geoprocessing or processing of the data. There's nothing like that. So you just get hold of the data, then start working with it. The second one is the instance or the services. Sometimes you can have the data and you have to use your laptop to process your results or for whatever you want to work with. And it's time consuming and your memory can also be consuming. And sometimes your machine can actually be at a place for a whole 1 week. And that time also you'll be praying there shouldn't be any light off, no internet interruption. So having access to the cloud information can actually help you. You can start the processing, turn off your machine, go home, open up the machine, see the progress. If it's going to take 1 week for it to load, you don't care. You don't actually worry about much internet connection. The only internet connection that you need to worry about is connecting it back, your machine back to the server. And you don't need much internet speed for that. So these things actually gives you the most benefit to be able to run the processes online without actually having a lot of physical challenges that you normally face when you are doing data processing. Of course, having a Python language as the basis is actually important, but as it stands, you don't actually need to have much knowledge in Python, even if you are sensing or if you don't want to do much coded work. So one of the things that you'll be doing that we'll talk about is some of the existing notebooks that are there that actually will make your life easier, pick it up and run it. So you talk about those ones alongside the way. And also the technical support. Sometimes working with data and finding challenges is sometimes very difficult because if you alone are working and you don't have any support or someone to assist you in sometimes debugging the error or the penalty that is comes up, it also makes it very, very, very difficult. So the DE Africa technical team is there to support you on that. If you have any issue, the team is there, and once you send it to them within 24 to 48 hours, the team will respond back with you with a solution. Sometimes the team actually have a virtual interaction with its users so that they'll be able to see what problem the person is facing and to be able to help them work with it. Thirdly, any information that you develop in digital, any product that you develop from Digital Earth Africa is completely free, even for commercial purposes. You don't need to write a reason to tell us why you want to use a product for a particular problem. So anything that you use is completely free. And just as I said, if you need more than a 32 gig RAM, up to 120, that's 15 core process plus 15 core processing, just request it. Then the team will be happy to let you have it. Is any other question? Okay, so
please, I have a question.
Yes, please.
Yeah. Please, can you conduct, for example, your land use land cover changes analysis online? Like you are saying, you don't have to download the satellite image. So
Yes.
assuming you are doing it online.
Yeah. Yes, you can actually conduct it online. You can do that online. As part of the session, when we are going through the notebooks, I'll take you through one of them, then actually see how it actually works for the land use land cover that you want to do.
Okay, thank you.
You're welcome, Mary. Okay, please, at this point, I hope most of you have been able to launch their sandboxes. Or is anyone having any challenge in relation to that? Okay, so silence means that everybody has been able to log in. Then let's move on. Okay, so now let's move on. So if you log on to your sandbox, sorry for my, okay, I think mine is also up. Okay. Okay, sorry for seeing a lot of folders in mine, but nevertheless, if you open yours, the most important folder that you will be able to see are the beginner's guide, the data set, frequently used code, the real world examples, the supplementary data, the tools, and the use cases. These are one of the things that if you like, okay, let me switch my screen. I think the other one is up. So let me switch to the other one, which has loaded up. Okay, perfect. So if you log on to it, this is what you are going to see from your side. At the top right is the memory usage that you are going to use and the CPU percentage. If you want to change the theme of the sandbox, you can do if you want the dark theme. But for this work, you're going to use the light theme. Some of the things also from the menu bar that we will be using most will be the kernel. And we also talk about the gates, which normally the sandbox is actually automatically connected to the GitHub page. So if you have your own Git page, you can easily connect the sandbox to it so that all the works that you do here, you'll be able to back it up on the Git. So anytime you switch machines or you are doing something and you want to call back whatever you are doing, you can actually use the key to call it back. But the repository or whatever you are seeing here belongs to you alone. No one from the team actually will know what you are doing unless you decide to share it with the team members what you are doing. Anything that you are doing here is for your own, so no one will see your code, whether it's confidential, whether it's a public data, no one will see it. All that you'll be able to do is you have access to this site for you to be able to work with. If it closes up, one of the things that you're going to see are the important updates. So every month there are updates. It's either you are updating some of the packages or you are making changes to some of the notebooks. If you visit this particular at the D Africa info, you're going to get all those information there and some of the things that are actually happening, the new things that are actually happening within it. So the regular task are actually connected to notebooks, so Python notebooks, which actually is easier for researchers to use. Because you don't actually have to go and download other books to use it, other software packages like Sublime Text, VS Code. You don't actually need to do that. With a notebook, it just makes it easier for you to develop a simple script without going through sometimes some of the hectic processing to follow through to get your results out. So using this one makes it very easier for users to actually know how to use it. So the first thing that we are going to go through will be the data sets. Previously, I made mention that you don't actually have to be an expert of the Python language before you'll be able to use the sandbox. This is the reason why most of the codes or most of the notebooks has been developed. So all that matters is for you to be able to look through it and use it. So one of the notebooks that I would like us to go through to be the World Settlement Footprint. So if you look at here, these are some of the data sets that we have on the platform, and we give you guidelines on how to connect to the data set and use it without actually going through anything. So we are going to go through some of the notebooks one after the other. Then after that, we just think we will move on to the next one. So the notebook that I would like us to go through, let's start with the Sentinel-2 imagery. Let's start with the Sentinel-2 imagery. Once you double click on it, a page will be open for you on the right-hand side. So you do that, then you also look at the World Settlement Footprint. I'm just randomly selecting some. Then you also look at the land use land cover maps or land use land cover maps. Also look at some of them. So if you open a new notebook without it, the first that will give you is the background information of that particular notebook, how it came to be, how it has been indexed within the sandbox, and how you can connect it to it. So it give you those basic information that you need to know about any data set. Then we give you the description of what is within the notebook, what the notebook actually entails for you to be able to know that. At this point, I hope everybody will understand this session. The first section, which is the load packages. In Python, any tool that you want to use, you actually have to import it and you have to use it. So for this particular notebook, the things that you wanted to use for this particular notebook is the data key, which is very, very important. The data set is built on top of the data cube. So all our analysis ready data sets is within the form of the data cube. Then the next thing is the package called the load ARD. The load ARD will load the data set onto the sandbox for you. So the load that the data set is already in a different database. It's not on the sandbox. So using the load ARD, you'll be able to load the data set onto the sandbox or onto your memory so that you'll be able to work with it. Then the load RGB is actually to plot, to visualize the visualizations. So this first package is very, very important for any Python notebooks, except for the basics one, which is inbuilt. The rest of them, if you want to use them, you have to actually import them. And one of the things that you have to import is the data cube and the load ARD. So the first section actually, if you look at the markdown, it's actually giving an information there, load packages. Then the next one is to create an instance of the data cube. Is to create an instance of the data cube, or because it's a class, you have to create an instance with it. Then you provide a name. This name can be any name. It doesn't necessarily have to be it can be any name that comes into your mind, but make sure that it should be a name that you can easily use it to identify the notebook if you are running it out. Then the third phase actually talks about loading the measurements, how to load the measurements within it. So at this point, if you want to know much about the Sentinel, we haven't written any code yet, but most of the information has been given to you as a guide. Just go through it and see what you'll be able to get into it. So the list of measurements gives you the bands, names, and the units and the aliases that's actually found within the Sentinel system. So the next step is to load the Sentinel-2 data using the load ARD or the DC load. Using the load ARD or the DC load. So at this particular point, it's very crucial for us to know. So using the DC load, you load the Sentinel-2 imagery, then you specify the measurements that you want to use. Then you provide your X and Y. That's the latitude and the longitude. That's the upper left bounds and the lower right bounds. So you provide the Y for the upper left bound and the lower right bound. Then you provide the X for the upper left bound and the lower right bound. Then you specify your time period, the time period that you want to load. This one, you only specify one period. I think let me check. Only one period was specified, but you can also choose to specify. So this one will specify the year and the month, but you can also choose to specify the year, month, day, or you can only go for year. So if you want to run it for a whole year, all that you have to do is you change the start year. Sorry, so this is the start year. What I've highlighted here is the start year. So you can change the start year, you can only specify it in terms of years. You just do 2018, 2019. Or if you want a particular month, you just add a month to it. So 2018, 2019, maybe 2019 December. And if you want wanted to specify the year also, you can add the date to it. But for this tutorial, let's stick to 1 month to it and 1 month to it. you are dealing with Sentinel-2 imagery. That's Sentinel-2A and 2B. And you know that for Sentinel-2A and 2B, the revisit period is 5 days for the Sentinel-A and Sentinel-B. So within a month, you could be expecting, you could get about 6 images, because every 5 days, you're going to get an image for the particular area that you are working with. You can actually get about that imagery there for that. Then you come to the resolution. One good thing about the data queue when it comes to resolution is, you know, resolution upscaling or downscaling actually becomes a problem by convention. So if the resolution of the image that you are looking for is 10 by 10, but you are dealing with another image that has a higher resolution, for instance, another image that has a higher resolution, MODIS, and you want to make sure that your Sentinel image, you're able to upscale it to fit the 100 by 100 resolution. All that you need to do is just specify that resolution number. So if I want this one 100 by 100, I'll just type 100 by 100 here. The function will automatically do the scaling for you to 100 by 100. If you want 30 by 30 meters, just make it 30 by 30 meters. Then automatically the system will do the scaling for you. So you don't actually have to worry about, I need to convert it to 90 by 90. How do I do that in the 90 by 90? And it's going to use the nearest method. You know, doing the array sampling, it comes with 3 methods for you, but this one, normally you use the nearest method for array sampling. So you don't actually have to worry your mind. Just pick up the value, put it there. When the data is being uploaded and it has to scale it up for you, it automatically do it on the fly. Then it will load it up for you without any worry. We also have the output CRS, the coordinate units. This is in meters for you to work with, and also have the group by in the solar. So once you have it and you load it up, these images are going to come. I just tell you. So right now, for this particular period, we had about 7 images showing up. So this is the image for the area that it was shown. So you can see we have these 2 images for Sentinel-2 for the area, study area you have. So if you have any area of interest that you need to work with, you can specify the latitude and the longitude, then it will give you that function. This session might be a little bit difficult because you have to go to a map and go and do it. So with the subsequent one, there's a shortcut method that when you go into the real world examples, you will be able to see that. So then you use the RGB function to plot it out just as you want to see your image. Within this session, we actually using the dc.load. But when we were importing, you notice that we work with the load_ARD. So with the load_ARD, it has more advantage than the dc.load. It has more advantage than that. And with the load_ADR, although it follows the same procedure, DC load only loads the native data type for you. But with the load ARD, it can actually load the reflectance values. If you want either the reflectance value or the native values for it. Load ARD also gives you the chance for you to filter the satellite image based on the clear cloud images. So with the DC load, you cannot actually specify if you want 50% of images to be clear. For this particular function, you cannot do that. But if you look at the load ARD function, you'll be able to do that. You'll be able to load and specify the mean width data that you are actually after. And you can clearly see how the DC load actually do it. It also do some cloud masking for you. So at the end of the day, some of the areas will be removed as compared to the DC load. So this particular notebook within the data set gives you an idea of how you actually connect to the system, to the database that you have within it for Sentinel imaging. Before we move on to the next notebook, please, is there any question or any clarification that you would like to have on what I just talked? If I also talk fast, please alert me so that I'll continue. I'll slow down a little along the way.
Yeah, going too fast for me.
Okay.
So maybe you slow down small. Maybe the rest they are okay.
No problem.
Hello, Eddie.
Yes.
Yes, I'm following it with what you are saying, but I want to find out where you specify the various parameters for the image. We could see CRS, ESPG 6933 and all that. Can we do it such that you can also get it in Imperial, where is there a way to also convert everything into Imperial so that we can also get it, or just everything has to be in meters?
Oh, okay. So if we are using the if there is a code for the Imperial, I have to check it I have to check it in QGIS. If QGIS have the code for it, you just have to specify it here. Then a system on the fly to do the conversion for you.
Yeah, because Ghana's ESPG is 2136, if I'm getting it right, if I'm right.
2136.
21, I think it's 2136.
That's right.
Yeah,
Yeah,
2136
in metric.
for GNG.
Yeah, but that is not in metric.
That's Imperial. No,
Imperial.
that's
the
Imperial
metric.
for ESPG for Ghana.
Oh, okay.
Yeah, okay. So if it's there, just put it here, then the system will automatically convert it for you. But please mind you, because you are dealing with Imperial, this section has to be in Y and the X. Otherwise, if you don't change those ones into Imperial, to throw you off.
That is it. Okay.
Yeah. So once you specify how you want to, once you specify the output underscore the CRS in this format, the 2136.
Yeah.
You have to make sure that the Y and the X is also changed to that session. Then automatically will be able to do it for you. I haven't tried the Imperial method because I'm just also thinking about the resolution. Will it affect it or not? So probably we can test it out and see what might come out of it. And I think I'm happy if you can run it at your end and give us feedback. Yes, and give us feedback on it.
Okay.
Okay, thank you. Okay, so please, is there any place that you would like me to go over it again? Or this session was very good. And the next session, I'll just take my time for all of us to go through it. Okay, so there's one particular notebook for it. That's how to load the data sets onto the platform. Let's check the other one. So the world settlement footprint is also another data set that is also on the platform. And just previously, as I said, we give you the background information of what the data set is all about and where you can actually use it. Then you talk about the description, what you are supposed to, what you are expected to see from this particular notebook that we have. Okay, so as I previously said, for every Python thing that you want to write, for every Python script that you need to write, you always have to know the packages that you would want to use. And most of the data set that you use actually makes it, Python has most of the packages for data sets. There's one thing that I forgot to add. Why are you using Python? Why not use other languages like JavaScript, MATLAB? Why but you are just using Python? As of now, one of the programming languages that really support data science and heavy data, big data processing is Python. And it actually makes it easier to do that interaction. So if you have big data to work with, Python is actually the go-to, because to actually help you to be able to process some of the data. Although sometimes some of the packages make it slower, they are the best for you to use it for processing of the images. So having this thing in mind actually will help you to be able to process some of your data. For instance, the Earth observation data set that you are using is actually a very, very, very big package, and actually consumes a lot of memory. But if you have the Python packages, you can actually be tweaking it, removing some, and just manipulating it to get the results that you want without actually it slowing down some of your processing. And Python right now is by far the package that has a lot of tools when it comes for data science and machine learning. Python actually has a lot of tools on that. So that's why we prefer to use the Python as compared to the other programming languages that we have. So as you can see, with this particular package, there are a lot of packages that were loaded for this particular notebook. The data cube, we saw it in the previous one, the NumPy, the pandas, GeoPandas, and the Seaborn. All these are Python packages for data science and machine learning, which we're actually going to deal with that. Then we have the matplotlib for plotting purposes. Then you also have the DE Africa tools packages. And as you can see, there is a new function here, which is called the define area. So the define area, you talk more about it when we reach the downstairs, when you reach the downsteps. So most of the things that you are seeing here actually are the packages that you will be using within what you are going to see from the next steps. There are a lot, but don't let it scare you. These packages are just there to help you to be able to achieve your aim. So the next step is to just define your instance, the data cube instance, which we have defined here. Then we wanted to inspect the measurements that are available for this particular world settlement footprint notebook that we have here. We inspect them. Then at this point, if you look at here, this is where the defined area comes in. With the previous notebook that we had, you notice that you specify the X and Y, value by value, value by value here. But if you look at this section, we have brought in the define underscore area package to make it simple for you. If you have your own shapefile, you can use this particular line. And you can only use just by uncommenting it. So by clearing the asterisks here, the sharp key here. So once you click the sharp key, this section will be available for you. But you don't have the shapefile for the area, so you stick to the first one. And what you do is you specify the centroid of the object that you are dealing with. That means you specify the latitude and the longitude. That's the centroid of the object. Then you specify the buffer area for it. If you have the shapefile in it, what you can do is you click on this button, what I've clicked up here, then you upload your shapefile, whether it's a JSON or a shapefile, any vector file that you have. Just click this symbol here, then you upload that vector file there. So once you upload the vector file, you come and uncomment this. Then within this section, you put the name of the shapefile there. So if it's Ghana, just type Ghana.shp. Please be mindful of the shapefile. Remember, shapefile is not just one file, it's 5 files. So make sure that you've actually uploaded all the 5 files before the SHP will work. The SHP is just one of the shapefiles files, but we are just talking about you have to upload all the 5 different files of the shapefile into it, then you change it. If you don't have the shapefile, don't worry. You can comment this one. So you can uncomment this one. Then you provide the latitude and the longitude. That's the center point. So you provide a center point, then you provide a buffer along the way. Once you change these two, The rest, you don't actually have to change anything. Just follow the instructions and it will take you to it. So at this point, we will load the area of interest. Sometimes when you specify the latitude and the longitude, you have to be sure that it falls within the area that you are working in. So you click on that section to do that. So at this point, I want us to go back a little. Then I would like us to start running it. Within the Sentinel-2, I didn't execute it, but this one I would like to execute it. So anytime you pick a notebook, an existing notebook, please make sure that it works before you do anything. That if you want to make any changes, you make that changes to it. And this is how you are going to do it. Come to the kernel, click on the kernel, then click on restart kernel and run all cells. Just click on that. Then this alert will pop up. Then you click on the restart kernel. So once you click on restart kernel, you see the asterisk. Once you see an asterisk, it means that the notebook is executing. Once it changes to a number, that means that particular cell, this cell has actually is done running. So you can move on to the next step. So as you can see, all these cells have changed. That means it's done running. This side has also changed, it's done running. Then this side has also now display up. So this is actually a map of Kumasi. So the latitude and the longitude that was specified was within Kumasi. So as you can see the buffer zone that is being covered. Okay, so remember we have the dc.load here. And here we are loading the 2015 products and the measurements. Remember that here we actually loaded all the measurements within the DC load here. But for here, we only, for the DC load, we only specify the product and the measurement. Then we bring something, a query here. So the query here is a variable name, and it's just at the top here. And you can see we specify the X, the Y, the resolution, the output underscore the CRS. The reason why we specify it as a variable is because we want to reuse this query again. So you don't want to be typing everything afresh. So you define the variable and store these parameters in as a dictionary. So that what we want to do is we just want it to, anytime we want to use it, we just call the query out without doing much work. And remember, you brought this double asterisk here. What the double asterisk would do it will treat this as an object. So just as we've listed them here, the double asterisk will treat them as an object, and we're going to have all this information available here. So with this one, we loaded the world settlement footprint for 2015. Then the world settlement footprint for 2019 was also loaded. But as you can see, the queries has come again. So we don't need to rewrite everything. We just define all of them within this variable query. So when I change something here, it will affect these two measurements, these two data sets that we are loading right now. Then the next step is plotting of this spatial data set, as you can see. So you are plotting a spatial data set, and you plotted them with two different colors. So one is 2015 and the other is 2019. That's as you can see here. Then this step was, you wanted to calculate, convert the pixel to area, that's kilometers. So you want to convert it to kilometers. So every pixel will have a value so that you will be able to quantify them and plot it out. So as it stands now, you can actually see we've plotted the area of settlement footprint for 2015, and also plotted it for 2019. And you can also clearly see the change that happened between 2019 and 2015. How much has increased also in the third step. And you can also do the spatial plotting. So the spatial plotting, just to see the areas that there was a change in it between those two particular years that we are having. So If you want to deal with urban settlement, just know what has happened between 22 different years. The rough settlement footprint actually is between 2015 and 2019. All that is needed is to get the latitude and the longitude, the centroid point. If you have the shapefile, that's it. That is fine. Change the latitude and the longitude. Then if you have to change the buffer, so you change it. Then you come to the kernel, restart kernel, and run all cells. Once you click on the restart kernel and run all cells, just don't worry, go through it, sorry, and you'll be able to see all the results that we have here. If you see the results and you're interested in it, one of the things, so there are two ways here to save the imagery. For if you are using Mozilla, when you right click on it, you can see save images. If you are using Mozilla, you can see save images. But if you are using Chrome, there are ways to save it. This is one of the ways. Click on the image, drag it, and put it in a new tab. You have the image here, then you right click it, then you save images. Then you'll be able to save the image as whatever you want to do. The same thing applies to the graph, and the same thing applies to the spatial chain between those two things. So, where you've reached, please choose a latitude and a longitude of a place. So you can go to Google Map or any place if you have a place in mind. Just pick any latitude and longitude, and please come and put it here. Don't change the buffer, just put it there, and please run it. And you'll be happy if you can share your results with us on WhatsApp right now. So I'll be happy. Let me give the team about 4 minutes. So if anybody is here, just change the latitude and the longitude, run it, and please share the results with us on the WhatsApp page right now. Then we will continue from there. So I'm waiting. And if you have any question at this point also, kindly let me know. Then I can answer it before we continue.
Hello, Eddie. Hello, Eddie. Hello, Edward.
Hello, Edward.
Good.
Eddie, your mic is off. Hello, Eddie. Let me get him on the phone.
Okay.
Michael, hello, Michael, I'm here.
Yeah, your mic has been
Yeah.
off. So
Sorry,
we have
I
to
was
miss-
sorry.
Uh-huh.
Hello, Eddie.
Okay.
Yes.
Hello, Eddie. I want to ask a question.
Okay.
Yeah, my question is, you see, what we just did is a 4-year interval, 2015 and 2019. So I was looking for where those years are to change it to maybe 10-year interval or something. Where is it?
Oh, okay.
Oh,
So
okay, I think it's here.
no,
Is it 1, 2, 3?
hello.
Hello, yes.
So this is the World Settlement Footprint. They only have it for
Oh.
2 years. That's 2015 and 2019.
Yeah.
So I think there's another notebook that we will go on it, and that one can also help us. Let me see this. Yeah. No, I don't think it's so. The other one, when you go into another folder, you'll be able to have the chance to do it between yearly settlements. So please let's wait for that one. But as it stands now with the World Settlement Footprint data set, they only have it for 2 years.
That's 2015 and 2019.
Yes, 2015 and 2019 as it stands now.
Okay.
Okay. Tomorrow you get to look at those notebooks. Let me see where urban change detection. So you look at these 2 notebooks tomorrow, whereby you'll be able to do the 10 years interval that you want. Hello, Bryson.
Okay, thank you very much, Mr. Edward. I wanted to find out with regards to the image, is it only PNG?
Okay, so the main image is there. If you want the TIFF, you can also download the TIFF. But this topic that won't cover the downloading of the TIFF. Tomorrow, we talk about how to download the TIFF as an end product instead of the PNG.
Okay, thank you.
Okay, I think the time is up. Please, was everybody able to run it for the area of interest that he or she wanted? Okay.
Yes.
Okay, so please, can you share it with us on the WhatsApp page so that you can all see your results there?
Kasua one.
You. Okay, thank you.
I did the heart of Kasua. Okay, then let me take a snapshot of it.
Oh, you didn't get, okay, so okay, you have it on your phone. So
No,
you got it.
I want to take a snapshot of it and send.
Okay, that's fine.
Yeah, okay. So this is.
Okay, so let's move on to the next notebook. These are just some of the notebooks that I randomly picked. But if you look at it, you can actually see you have the Alu Pulsar annual mosaic. We have the ERA 5 climate data. We have the coastlines. We have the cropland extent. We have the digital elevation model data set, the fractional cover, the GeoMAD, the global mangrove watch, the high resolution population density data, the ISDA soil data, the land use land cover map, the land cover classification, the land surface reflectance, the land surface temperature, NDVI anomaly, NDVI climatology, OpenStreetMap, rainfall chips data sets, the rolling GeoMAD, Sentinel-1, Sentinel-2, soil moisture water observation from space, and the World Settlement Footprint. All these data sets are available on the platform, and we just give you a guidance on how you can connect with and some of the things you can use to work with it. So the land use land cover actually deals with about 5 different land use land cover images from different products. So you have the IOL, the Environmental System Research Impact Institute, and the Impact Observatory land use land cover. You have the European Space Agency world cover. You have the Copernicus land use land cover. Then you also have the ESA Climate Change Initiative land cover. So all these land covers are available on a platform. You give you the detailed information as previously, then you see which areas have to be packaged. They also have the product name also available here. So this session also, you specify the latitude and the longitude. Just look at it and see how they specified it. And look at the buffer and also look at the resolution. That's 500 by 500. That means all the 5 images that you're going to deal with it, you are going to resample them into 500 by 500 meters. So the most important thing that if you need from your end is the latitude and the longitude. Just change that. The rest you can maintain as it is if you really want to see how it's going to work. Then you click on the kernel, restart kernel and run all cells for the area that you want to work with. So as you can see, this is the plotting of the various land use land cover across different sections. So you have the SG, ESA, CGLS, and also you also have the CCI land cover. So this is going to further investigation of the imagery. So this the land use land cover for a particular area that you can actually work it out, type it. Then you calculate the area for the land use. So there are a lot of codes here, but don't worry about it. The most important thing is once you change the latitude and longitude of that particular area that you are working with, it's going to take effect here. Then you're going to see the results here. Then if you move down, you also see the difference between the 2 areas that we have here. So I'm going to pick a latitude area for the Kumasi, which I have here. Let me pick that one up. So I'll pick the lat 6.6 something. I'll pick it from here. And I'll change it here. I think I saw 2 latitude and longitude. So I'll change it here. Then I'll come back, then pick the longitude minus. I'll click it, then I'll change it here. Then let me move forward downwards again. Then I'll pick it, then I'll change it here. So those are the most important ones that you do. Then you click on it, then go to restart kernel and run our cells. I click on restart kernel and run our cells. Then you wait for it. So as you can see from below here, you actually see that it's running. So the memory, 3 memory gigabytes it will use. Then you give it some time. So this one has been run, this one has been run. So as you can see, the CPU is working, but we're only using 3.35 gigabytes of RAM out of the 30 gig. Then it's running. So you just give it some time, then it will run. So this ESA will cover 2020. That means it's only for 2020. Then this is for 2021. Then the CLGS land cover is 2019. Then the CCI land cover is 2019. So one of the questions that comes up is, so how will I know the time span of your images? Because you are working with it. There's a place where you can actually inspect the metadata for all these images, and it can be found at, let me open a new tab. So it's explorer.digital-africa.org. So I'm putting it within the chat. There's a chat. Okay, perfect. So here you get to see all the metadata sets for all the satellite images that is available on Digital Earth Africa. So you can scroll down. Let's check the Landsat 5 level 2 resolution, surface reflector, another surface temperature. So once it's loading, you will check. Oh, it's still loading. Oh, okay. The resolution was very big. I chose a very big resolution. Okay. So if you load the metadata of Landsat Sentinel-5, I think it's still loading. So while it's loading, let me go back to it. So I gave it the coordinates, but I made it, the buffer was very big. So it's covering a whole lot of area for Ghana. But as you can see, the buffer is within Kumasi. The lat and long is supposed to be within Kumasi. Wow. So these are the results you're going to get for the various areas. Then it can calculate the area for you. Then you can see, based on this, the things that has been changed. So for the land use land cover classes, for the SG or the IO land cover, you can see water, trees, crops, build up, background, and rangeland. So you can see how much has been affected over the period of years. You can actually visualize some of this to see the results for that particular area. Okay, yeah, perfect. So here you can actually see the coverage for Landsat 5 that starts from March 1984 up to November 2011. Hello, Dr. Mary.
Hello. Please, sorry if my question has already been asked, but my internet has been going on and off. Please, assuming you have a predefined area, like Sunyani West Municipality area, and that is solely the outline you want to show, can you load it here?
Yes, please. Yes, please. Okay, let me quick one. So within the previous, so for this particular notebook, we didn't use the solely defined area for it. We used the centroid, but there's a notebook here, the world settlement footprint. And we had a function called the define underscore area. So with this define underscore area, if you're using this function, you have the opportunity to import your shapefile. So that's how you do your import your shapefile into it. You click this symbol here, then it will open the dialog for you, whereby you load all your shapefiles onto the browser site, or this onto where the notebooks are. Then when you come to the vector part, you specify it. So if I'll give an example, let's assume you want to, right now here we are just specifying the latitude and the longitude, but right now you want to add the defined area to it, so that you can add our shapefile to it. So this is what you will do. This is not another, so you can easily do copy and paste. So please come and copy all these cells. Just copy everything here, Control C, come to the land use land cover. Then replace it with this side. Then you replace it with that side. So once you replace it, once you replace it, because things change, you also have to update this section. Sorry. You also have to update this section. Then you can, we've already defined the bounding box here, so you can delete this one. So if you have the shapefile, you click on this symbol, you upload the shapefile, then you specify the shapefile name here. So the shapefile is Sunyani West, just provide the name there. Then you click on kernel, restart kernel and run on cells, and it will run everything and just give you only the area for Sunyani without adding the other areas that you don't need there.
Okay, thank you so much.
Sorry, there's one thing I forgot to add. Because you are bringing the defined area, it's an importation. So you have to make sure you copy this one also over to where we import the files. I easily forgot that. So where are you? Yeah, so you add this one to here, then you are done.
Okay.
Hello, Bright.
Okay, Mr. Edward, how will you be able to check the accuracy of your work? Is there anything like an accuracy of your work if you have to check what you are working on with?
Oh, okay. So there's an accuracy assessment that you can do if you have a validation data set that can be imported, and you can just validate the results by extracting the pixel values as compared to your data set that you have. So there's an accuracy assessment that you can do. Okay, so this one will bring us to the end of today's session. As you can see, you've been introduced to the data sets available. So I'll be happy if you can take the time to go through it, play around with the data set. Anything that you are doing here, it won't actually affect your work or nothing will happen. Just play around with it. And if you have any question, put it on the WhatsApp page or you can share it with us. Then you'll be able to give you a response on it. So this is where I would like to end. Then tomorrow, we would continue our discussion.
Eddie,
Hello, John.
yes, I wanted to find out, is there any instance you can also write your own script from scratch without modifying the existing ones? Is that possible?
Yes, yeah. Tomorrow you will do a sample test for all of us to follow it and see how we are going to do.
Yeah, I think that is also going to be helpful to solidify the understanding.
That'll be fine. So we will do that.
All right.
So tomorrow's session is actually going to be 3 ways. We'll move on to the next step, which is the real world folder, and talk about some of the notebooks there, but very quickly. Then the second, so with the real world folder, we talk about how to download the data sets. They also look about some of the images that you can also use for mapping, annual mapping that you can actually use for it. Then you will start with a hands-on training, just to build something from scratch, whereby you're just going to do it for it. So that's what tomorrow you'll be focusing on.
Hello.
Hello.
Yeah, I want to find out, in all the notebooks, is there anywhere that we can also download a vector data? Because what we did was just an PNG and seems to be raster data set. Can we also have an instance where we can download vector data from any of the notebooks?
Yes, Kamala. So just as I said, tomorrow we'll talk about that.
Oh, okay. All right.
Yes,
all right.
We'll talk about tomorrow.
Fit.
Okay.
Yes, Eddie. So as you are talking about, yes, all of this, they need to come in with some announcement. So yesterday I reminded us that we'll be having our conference in November 30th, and we'll be having induction of members. And for this session or this period, we'll not be doing examination. We require that you register, you create an account on the website. That's the ggs.org.gh. It's in the chat. When you get there, you register and you upload your document so that at least your document will be assessed and then you'll be admitted. I'm sure those who have applied are getting responses, and you'll be getting emails also following up. And if you don't do that, yes, that means you'll not be admitted with this badge in November. And then the subsequent badges, you are most likely going to write an examination to go through. So there's a window that has been given by the governing council that we are admitting these people by just evaluating their documents. So you should take advantage of that. Go to the website www.ggs.org.gh, create an account. When you are creating the account, you will get your password either sent to you by SMS or in your mail. You use it to then create the account, and then you log in, you register, and then you upload the necessary document. If something is missing, I'm sure you'll be communicated to by the committee working on it, and then you complete the process properly. I'm sure they are communicating with most of you who have applied and one or two documents are missing. So please do take some time and then you do register so that you be admitted properly, because we'll be doing that in admission and induction at our conference in November 30th. Thank you very much. Yeah, you
Okay,
indicate
Chair,
the various
just a
working
quick
groups.
question. Chair,
Yes,
just a
please.
quick question. There's with regards to your particulars or your qualification, I saw that it wasn't mandatory. I don't know whether that is what is causing mine not to upload, because I tried again, it's not uploading.
So we can talk about that off air
Okay.
afterwards.
Okay.
Yes. So
Okay.
make sure you have all the necessary files and then check the formats of the file, because the formats are also indicated there.
Yes.
Yes.
Okay.
Thank you. Thank you very much, Eddie. Yes. So if there's no question, then I
Hello.
don't know. Yes, please.
Please, sorry, I'm trying to save. We said when we are saving, we should go to kernel.
Okay,
Hello.
yeah, hello, Doc.
Yeah, you said when you are saving, you should go to kernel and
If you want to save an image,
yes.
okay, so if you are using Chrome, what you do is you click on the image, then you drag it to a new tab. It will come here. Then once you click on it, you can click Save Image As.
So you have to send it to a new tab.
Yes, but if
Thank
you are
you.
using Mozilla, right?
It's my group.
Okay, then you drag it out and save it.
Thank you.
Okay. Okay, so thanks everyone for joining us for this evening session, and we hope to see you tomorrow. Please, if any question comes up along the way, feel free to ask us on the WhatsApp page, then we'll be happy to respond to you. So thank you, everyone.
Thank
Hello,
you,
Mike.
All
Eddie.
right.
Okay.
Yes. So maybe
Yeah,
more
you-
questions.
No, it's not a question. I was just handing over to you.
Oh, okay. Yes. Yes. So thank you all for coming for today's session. I think it's been interesting. And now that we are applying what we have learned in the Python, I am sure that there's more to it. I am keenly interested in writing all my scripts that will help me predict a few things. And some of us, we like to write more scripts. We don't want to edit the ones that are there, like Isiama's accent. And I'm sure a few others want to do something like that, because we have been learning so much on Python for the past 6 or 7 days. Now we want to try our hands on writing some plenty lines of codes so that we can see how the images will be changing with what we think we know, like this classification and all of these other resampling and everything. But I'm sure we can do that from tomorrow, as Eddie has promised us. So yes, if there is someone else who wasn't here, let's try and remind the person to join us, and then we can enjoy our session. I'm sure later, as is part of the objectives of this particular working group, their objectives, they said we'll be organizing some hackathons and then various sessions for people to come and display their skills. And maybe they'll be giving awards for those people who need to solve real-time problems with it. So let us continue learning, let's practice. And then maybe that time we can also show our skills for something good. Thank you very much. And we can enjoy the evening. Dr. Kuya, I can see you are online. I didn't hear your voice.
I joined late, so I was just following.
Yeah, how is Tamale? My satellite
Yeah,
signal in Tamale.
yeah, it's going to be great. We've got a lot of people here, so we are hoping tomorrow we have a good opening, and we hope to have a good seminar.